Didn't have that going. I'm going to write some equations and have you help me solve them. Okay, what's the first thing you want to do? And read me the next line. Let's just do it step by step and not take any shortcuts. But what would your first step be?
Do 3 times x and 3 times negative 5.
Okay, so the next line reads 3x. Keep going.
X minus 15. Plus 7.
Yeah, okay.
Yes.
Okay, now what's the next step?
Add the negative 15 and the 7.
Okay. So what's that line?
3x minus 8.
And now these last two steps you can do at the same time if you want. You don't have to do them one by one. But the concept is we're going to get the x's on one side and all the numbers on the other.
So minus x from 3x.
I'm sorry, what?
Minus the 3x.
Okay. Let's think about that for a second. If we do minus the 3x, I'm going to have a negative sign in front of x by the time I get it on the right side. So
okay.
It makes more sense, excuse me one moment, it makes more sense to move this 2x to this side because that's going to leave us with just x with a positive sign in front of it. It's not that we can't handle negative signs, it's just that if you have a choice, you'd always prefer your signs to be positive. Not only that, but now when I move this 8 to the other side, I'm going to have 18, a positive number also. Okay? Here's what would have happened had we done it the other way. Well, I moved this over to there, so I have 2x minus 3x, so you're right, it would have been negative x. And then if I move this 10 over to this side, I'm going to have negative 18. And so now I have one more step I have to do. I have to divide both sides by negative 1 to get this. Okay. Now, there's nothing wrong with having the x on the right side of the equation. That's perfectly acceptable. And I have no problem with that at all. But people make mistakes when dealing with negative numbers. And so, and it's just natural. I don't mean you, I mean everybody. So if you have a choice, like we had at this point in solving the equation, as to whether to move this 2x to the left or move the 3x to the right, try to go in the direction that's going to leave you with a positive sign.
Okay.
Let me see, I'm just kind of making these up as I go. Hold on, let me change it for a minute.
Okay.
Make this. What would your first step here be?
Add the 3 to the x and the 4.
You mean multiply the 3 by the x and the 4?
Yeah.
In other words, that was your first step on the last problem, if you remember. We had to get rid of those parentheses. Well, sometimes the better first step is to get rid of the denominator. I'm looking at a fraction here. I'm actually looking at 3/7 times x plus 4. In other words, I could have written that left side of the equation exactly like that. Same thing. No difference between the way I wrote it and this down here. But if we look at this as multiplying both sides by 7, which is going to get rid of my denominator, which is what I want to do, multiply that by 7. Okay, so now we're left with this. Now, again, we have a choice of steps. I can multiply this out so that I have 3x plus 12. I can multiply that out so that I have 42, and then I can go from there. But there's actually a better way to do this one. How about instead of distributing this, we get rid of the multiplier also? In other words, we can easily get rid of this 3 by dividing both sides by 3. And now I'm left with this. Notice I haven't had to deal with a big number yet. Biggest number I've had to deal with is 7. Okay. Now, on the right side, I don't need to multiply 6 times 7 and divide it by 3. I want to reduce this first. So how do I reduce this?
Make the 6 3 and the 3.
Almost. Make the 6 2. Because what I'm really doing is I'm reducing 6 over 3 to 2 over 1. And the way I'm actually doing that is I'm dividing the bottom by 3 and the top by 3. Which means is all I'm doing is dividing this whole thing by 1. Well, you can divide anything by 1, always, without changing its value, just like you can multiply it by 1. Okay? So when I do that, I now have 2 times 7 over 1. Well, I don't need to write the 1. And on the left side, I still have x plus 4. Well, now I have to multiply this out. Turn that into a 14, and then subtract 4 from both sides, x equal 10. Okay? So this is just an example of the numerous ways you can solve equations. But you always want to do it with a couple of things in mind. You want to do it by keeping your numbers as small as possible if you have choices, and keeping your signs positive instead of negative. You'll still get to the right answer if you don't do those two things, but it'll just make life easier. Okay, so that was... Now let's look at this problem. Now notice this is different. Not just because it's plus 4, but there's no parentheses on top. Okay?
Yeah.
So what's a good first step here?
Get rid of the 7.
Yeah, get rid of the denominators is always a good first step. So what's the next line?
3x plus 4
equals
5.
Now hold on, I can't multiply the left side by 7 unless I multiply the right side by 7. In other words,
35.
When I get rid of the denominator, I do it by multiplying that side of the equation by the denominator. So now I have 35 over here. Okay. Now, you can solve the rest of this easily enough, I know. Let's alter this thing slightly.
Okay.
Instead of the plus 4 being over the fraction bar, I'm going to move it to there. Okay?
Okay.
Now what's the first step?
To divide 3x by 7.
Can't do that. That's already being divided by that. So
Then
In other
add
words,
3x with 7 by 4.
basically have two choices here. Do we get rid of the 7 first, or do we move the 4 over first? Move the 4 over. Because notice what happens if I try to multiply that whole thing by 7. I do get rid of the 7 from this term, but then I got to multiply 7 times 4, which is 28, big number. So before you get rid of denominators, get rid of anything that's whole numbers that are being added or subtracted. Okay, so I'm going to do minus 4 from both sides. And now I've got 3x over 7 equals 1. Now it's a lot easier. I'm not going to have any big numbers.
Yeah.
Now when I multiply both sides by 7, I end up with 3x equals 7. And finally, x equals 7/3. But by doing it in the way that I did, much easier than multiply. In other words, you have to always be making these decisions as to whether you get rid of denominator first, parentheses first, or things being added and subtracted. Okay? So those are the choices you have when you're solving equations. Let me see if I can think of a... You know how to solve that?
No.
What would the first step be?
Find out what the square root of x is.
X is a variable, so what we're trying to do is solve for x, but in order to do it, we have to algebraically work through this, and we're going to end up with x equals some number. Okay?
Add 1.
Add 1, okay. So now I got square root of x equals 3. Now how do I get rid of the square root part?
Divide it by the
Square it.
Square.
In other words, if you do the opposite, remember that solving equations is always about doing the opposite of what you're looking at. Right now that x is being the square root of it. Well, if I square that, it turns into just x. If you take the square root of x times the square root of x, you get x. Now this might be stuff you haven't had before. Have you dealt with square root radicals?
Not really.
No, not much? Well, you will. So, but again, because I squared the left side, I have to square the right side, and I end up with x equals 9. 3 squared is just 3 times 3. All right. Let's talk about factoring, because I noticed our last session, we really got into quite a bit of factoring. So let's review. There's 3 kinds of factors, and you always want to look for factors in this order. Okay? You want to first of all search for greatest common factor. An example of that would be what's the greatest common factor of that expression?
2.
Okay, so I'm going to factor out the 2. And when I say factor it out, it means divide each term by 2. Okay?
Yeah.
So what's left?
2 times 5.
Hold on. What's that equal to?
3x.
Okay. And what's that equal to?
5.
Plus 5. I can't not use the plus sign here. Okay? Because now, after you've taken out the greatest common factor, what you've essentially done is taken this expression and unmultiplied it. I've represented this thing as the product of 2 things. It's now the number 2 times the quantity 3x plus 5. So
Yeah.
as you're doing this greatest common factor, it's really valuable to check it as you do it. In other words, the moment you figure out what that is, multiply that times that, make sure you haven't changed it. It's still 6x.
Okay.
Same thing with the second term. Okay? Let's do another greatest common factor. And regardless of the expression that you're dealing with, if the problem says factor it, this is always your first step. In fact, I'm going to change this, make it this. There's a reason. No, in fact, let me make one more change to it. Make it a better problem. What's the greatest common factor?
5. 5.
What's left?
X, 1x squared.
Okay.
Or x squared minus 4x.
Okay. 4x?
Yes.
Okay. Now examine this expression. Is there anything, can I take anything out of that? In other words, if I can still take something out of this thing, then I haven't gotten the greatest common factor. The greatest common factor was actually 5x. Okay, because and the definition of the greatest common factor is, can it divide into that expression and come up with a whole number? And yes, you get x, which satisfies the requirement, and I can divide x into this and get just 4. So always include the variables when you're seeking your greatest common factor. One more change. Okay. What's the greatest common factor?
5x.
Good.
Still?
What's left?
X squared minus 4.
Okay. Now, if we examine that, there's no more greatest common factor that I can pull out. But if you look at that, what is that called? There's a name for that. It's the difference of what? Difference of perfect squares. Notice that x squared is a perfect square and 4 is a perfect square. And so that's the second kind of factoring. And it really helps if you memorize it by its name. Difference of perfect squares, because that spells it out perfectly. In other words, we need two things that are perfect squares and we need to be subtracting them. Okay? So, this is the second most simple form of factoring. And when I have the difference of perfect squares, like that, a squared minus b squared, it always factors into the same thing, a minus b times a plus b. That's what makes the difference of perfect squares so simple. So, how does x squared minus 4 factor? What's a going to be? In other words, right now, the x squared matches the a squared. So, x must be a, or a must be x. So, it's x minus what?
A squared.
In this case, we're looking for b. Remember that this is going to be a minus b times a plus b. Well, if b squared is 4, what is b?
4.
It's the square root of 4.
2.
2. And then the second part, you don't even have to think about it, is just the conjugate. The conjugate meaning same thing, opposite sign.
Yeah.
Okay? So, now I've fully factored this expression. When I had it to this step here, is all I had done was taken out a greatest common factor. Well, the goal is always, in all of these factoring problems, is to get it down to its smallest linear factors, if you can do it. Numbers and factors. And the reason being is that if I set up an equation like that, in other words, instead of an expression, if I actually give you an equation and say solve it, well, the only way to solve this equation is to get it to be a product of a bunch of stuff. As long as I can say that 5x times x minus 2 times x plus 2 is equal to 0, well, now I can come up with solutions. The only way three things multiplied together is equal to 0 is if each one of them can be 0. So this could be 0, which means x equals 0 is a solution. This could be 0, which means x would equal positive 2. Or this could be 0, which means x would equal negative 2. And those are the three solutions to this equation. And the only way we were able to come up with them was by breaking this up. Right now, the way this thing started out is we had something being subtracted from something else. Well, that doesn't work when you're trying to solve an equation, but I was able to take this whole thing and turn it into the product of three things. And that's the key, and that's why factoring is so important. Factoring is huge. It's something that you're going to have to be doing for the next 4 years. So if you can get good at it, you're going to really give yourself a head start. Okay? And that's it for today, but we'll do more factoring of quadratic expressions next time, like this. We won't do this, but I'll just put it up here. In other words, if I have an expression like that, I can't take a greatest common factor out of there. It's not difference of perfect squares. So the only thing left to do is to split it up into a linear term here and a linear term there. Now, when I multiply these two linear terms by one another, they give me that quadratic. So it's a similar process in that we're taking something and unmultiplying it. Okay?
Okay.
All right, Jen, have a good one, and I will talk to you Friday morning.
Okay, thank you.
You're welcome.
Bye.
Bye-bye.